Okay, we are still practicing graphing linear functions with a table and writing equations given a scenario. Just one more reminder that your cumulative exams, I know I still didn't pass them back. We still have a couple more people that are finishing. By the end of the week, I'd like to pass those back. So yeah, Jake, in here, you need to finish yours. But other classes, we have a handful of people that need to finish, okay? So if you still would like to see it, it's coming, I promise. All right, the warm-up today was a little bit different. You have not seen a scenario written this way yet, but I wanted to get you to start thinking about this before we keep practicing problems today. So if the problem says Mrs. Williams has 4 Starbucks drinks and purchases 3 more every 4 days, what's the equation in slope-intercept form? Matt, what do you think? How did you get that? Awesome. This part right here, as Matt said, very good, Matt, is the rate of change. That's what's changing. She's purchasing 3 more Starbucks drinks every 4 days. That is your rate of change. How do you typically see this? How is this normally written? You guys remember? Instead of 3 more every 4 days, how have we seen it so far? Sage? You're right, yes. So how would the 3/4 typically be written? Jake, do you know? Yes. Typically, it's written as purchases 0.75 drinks every day. Yes. You will start to see by the end of this week, Ms. Wingrove will start to teach you on Friday more about problems like this. So you'll start to see more problems like this. Instead of in decimal form, they'll be all mixed up. Raise your hand if you got that right. Just curious. Okay, so easier than I thought. Good job. All right, let's go over homework, and then we're going to do a couple more problems together. Okay, so starting with number 6, the scenario was given to you. I'm going to read through these. Yeah, I'm going to read through these, and then if you have questions, let me know after I go through it. I'm just going to shut the light off for these problems. In the back, can you guys see that? Ms. Wingrove, is that too little? Okay. So scenarios up there. X is day, Y is miles. When I checked homework today, a lot of you did not have 3 different forms of slope. You must have 3 forms of slope. I know it's maybe annoying to some of you, but you need to have 3 forms for your test. Slope should be change of y over change of x, change of miles over change of days, and then 3 miles over 4 days. Make this a little bit bigger for now. So 3 parts for slope. Y-intercept with labels, 0 days, 0 miles. Slope-intercept form equation is y equals 3/4 x. Standard form, I'll put a little box around, is 3x minus 4y equals 0. So let me pause there for a second. Questions on the first part of your template? Amy? The slope? Okay. So remember in class yesterday, after we wrote down the scenario, we identified x and y. We then went to the equation. So after you find x and y, I would write down your equation in slope-intercept form next. And then remember, the number next to x is your slope. So then I take the 3/4, which is 0.75, and write it as the slope. Is that what you mean? Or where did these 3 parts come from? Did you have 0.75 on yours? Okay, yeah, just always convert that to a fraction. If you have 0.75 miles over 1 day, same thing as 3 miles over 4 days, because 0.75 is 3/4. And for slope, just one more reminder, you need to have change of y over change of x, because it's the change of y. It's change of miles, which is y, over change of days, which is x, and then plug the number in, or you can plug the decimal in first. That's your call. Anyone else have questions on that part of the template? And please ask if you do. Okay, let's go to the graph. So you need to label the axes. The x-axis is days, y-axis is miles. I would use table values of 0, 4, and 8. Well, why would we, actually, you guys can tell me. Why would I use those values? What happened to 1, 2, and 3? Well, good job. The change in days is by 4. Look at the denominator of the fraction. whatever number goes into that. So 4 goes into 4, 4 goes into 8. You'll end up with a nice y value. You don't have to do this, but if you end up with decimals, it's just sometimes hard to graph. But your call. Your graph should be an increasing function because the amount here of miles is increasing every day. Any questions on any part of this? Okay, remember, if something's wrong, fix it. If you're not sure of something, please ask. Okay, number 7. Scenario was Jim has $12 and pays $1.50 for lunch each day. X is day. Y is money. I put lunch money, but really a lot of you I know had just money for the y variable. That's fine. The slope is change of y over change of x, which is equal to change of lunch money or change of money over change of day, which maybe some of you have as equals negative $1.5 over 1 day, which reduces to negative $3 over 2 days. So again, 1.5 is the same thing as 3 over 2. Use your calculator, type it in, hit math, enter, enter. The y-intercept is 0 day, comma, $12. Slope-intercept form is y equals negative 3 over 2x plus 12. Standard form is 3x plus 2y equals 24. For number 7, questions on any part of that template before I go to the graph? Okay, let's go to the graph. The axis, lunch money or money, should be the x-axis. Day is the y-axis. The graph is decreasing from left to right because this person is spending money. The table values, I used 0, 2, and 4. My values are up here, so check yours. And again, I use those because the fraction here was negative 3 over 2. 2 goes into 2, and 2 goes into 4. And then all you're doing is taking the x value, you're plugging it in for x in slope-intercept form and finding y. Jake? That's fine. You just end up with decimals. And that's fine. Yes, if you have a decimal, that's okay. There's nothing wrong with that. Miss Wingrove and I will just continue to use the nice numbers. That way it's easier to graph. But you do not have to choose those. Anyone else? Questions? Maggie, are you a little better? Yes. Your calculator. That's fine. There's someone in our fifth period class, the same issue. On a test, I'll give you a calculator to use, or I'll just tell you what the fraction should be. That's the only issue you're having? Yeah. Okay, that's fine. Anyone else? Okay, one more. Number 8, this was the tree problem. X is year, Y is inches. Slope is change of Y over change of X. Change of inches over change of year, 1.25. You can think of this as 1 1/4. And if you change your mixed number to an improper fraction, it's 5 over 4. So 5 inches over 4 years. The y-intercept is at year 0. The tree is 8 inches. Slope-intercept form is y equals 5/4 x plus 8. Standard form, 5x minus 4y equals negative 32. Questions on the first part of that? I see some writing, so I'll give you a minute here. Any questions on anything? Please ask if you're not sure. Okay, let me go to the graph. Okay, the graph, the x-axis is labeled as year. The y-axis is labeled as inches. I scaled the graph by 2. Whoops, I think I forgot to tell you that. And the other one, also I scaled the graph by 2. You may have realized that, my fault. So 7 and 8, I had a scale of 2 on the graphs. Because my table values went up on this one to 18, if you did what Jake did and maybe used 0, 1, 2, 3, and you didn't care about the decimals, then you do not have to scale it. Okay, just depends what values you use. I chose 0, 4, and 8 for this one. So just check your values, make sure your graph looks very, very similar to mine. Questions? Give me a thumbs up, thumbs middle, thumbs down on those problems. We're going to do more of them today, but I need to see your thumbs. Okay, thank you. Okay, I need you to take a blank sheet of green paper, so go to a side that doesn't have anything on it. I want to do 1 or 2 problems with you, and we're going to start with this one. You just need your green template paper. And since we're just doing this in class today, let's call this number 1. Okay, so we're going to do, again, probably 2 of these together, and then I'd like to give you time in class to work on some problems so I can walk around and make sure everyone's okay. Okay, so number 1 for today. This is from the notes. It's one that I want to make sure that we get to. The other problems are problems that I just made up. So Mary owes $20 to her credit card and charges $5 to it each week. First thing that I want to say is please remember that this problem is like you're spending money. If you're charging money on a credit card, you're spending money. So before you go any further, cross off where it says 2 lines. And then underneath the work part, go ahead and make a table, just like yesterday. Cross off where it says 2 lines. Underneath where it says work, make a table. I'll go back to the scenario, sorry. If you want to get started on identifying X and Y, that's fine with me. We're going to go over it in a second anyway. Once everyone has the scenario written. Okay, ready? So Mary owes $20 to her credit card and charges $5 to it each week. Can someone tell us what X is in this scenario? Well, what's X? Good. X is week or weeks. What is Y in this scenario? Zach? Good. Money or money charged, however you want to think of it, whether it's charged or just money, you're still spending money. Okay, let's go to slope-intercept form equation. I always go to that next. Amanda. She owes $20 for her credit card bill, plus she charges more to it. So that means that she previously spent $20 on something else because that amount is left on her bill. Does that make sense? Okay, so both of these are minus. I know that's a little weird because she's spending money. Yes, you could think of these as both positive because your credit card bill is increasing. Okay, but we're going to assume and think of this as spending money. So both of them are negative. Travis, you're with us, right? Okay, so let's now go to slope. Without looking at another green template, what is the first thing we have to write for slope? John? Good job, and you weren't even here. Change of y over change of x. What is the second thing you have to write for slope? Sage? Good job, change of money over change of week. Okay, now what? What's the last thing that we've been writing for slope? Will? Good job. Negative $5 for every 1 week. Okay, what is the y-intercept with labels? What is the y-intercept with labels? Really, all of you should have your hands up. Amanda? Good. At week 0 or 0 weeks, she has charged negative $20, or I should say she has charged $20. We abbreviate or we use the negative sign there to indicate that she has charged that amount. She has already spent $20. So she doesn't have $20 that she used to have. Okay, next thing, standard form equation. Dirk, how do we get this in standard form? Good job. So we need to add 5x to both sides. So standard form is going to be 5x plus y equals negative 20. We're adding 5x to both sides. So 5x plus y equals negative 20. Questions so far? Okay, let's go to our graph. Let's label the axes. Week is X, money or money charged is Y. Does it matter what table values that we pick for this one? No, it doesn't matter, right? It's not a fraction. I am going to write the equation like I did yesterday above the table. Y equals negative 5x minus 20. Let's use 0, 1, and 2. If we plug 0 in for x, Haley L., what is y? Good, negative 20. If we plug 1 in for x, Maggie, what's y? Careful, plug 1 in. So negative 5 minus 20. Good, negative 25. If we plug 2 in for x, what's y? Travis? Good, negative 30. You end up with negative 10 minus 20, which is negative 30. If you need to plug this into your calculator to find table values, go for it. Okay, let's graph. We need to scale this. Let's scale it by fives. So let's do 5, 10, 15, 20, 25, 30. So there's our y-axis scaled by fives. Let's keep the x-axis by ones, just because we use 0, 1, 2. So there's no need to scale that by fives. Okay, so let's graph 0, negative 20. And I guess I should be putting these on the bottom here too, sorry. Okay, 0, negative 20 is over 0, down 20. 1, negative 25, over 1, down negative 25. Remember, we scaled the y by fives. And then over 2, down negative 30. Okay, who can remind us from yesterday? What is the rise over run part of the graph? Will already explained this, so can someone else remind us or explain what is the change of y over change of x part from the graph? Jake, you want to try? Awesome. So the change of y is this way. Change of x is this way. Now, yes, we scaled this by fives, so it's going to be down 5 to the right 1, down 5 to the right 1. I scaled this by fives, but I kept this as ones. This is not the best graph to talk about this, but you get the point. So the change of y over change of x is the same thing as the rise over the run. Okay, before I have you go to your notes, questions on this problem. Okay, I need you to open up your notes to page, you have to write one more thing down in here, page 11. Okay, on page 11, there are some conclusions that you need to write down. So the first one asks us, why does the slope equal change of y over change of x? So we're on page 11 in the notes, pink packet. The first thing that you'll see underneath number 8, which we already did on the green template, is why does slope equal, I want you to write down change of y over change of x, which is equal to rise over run. It's page 11 in the notes. And basically, we are just going to write down what Will mentioned yesterday and what Jake mentioned today. The rise, which you're going to write underneath, the word rise is already there for you, represents the change in the y values. So you go up or down. So rise represents the change in the y values. That's why you go up or down when you say change of y or when you say rise. The change in the y values is the same thing as the rise. Okay, the run represents the change in the x values. So you go left and right. So the rise is the change in the y values. The run is the change in the x values, which is why you go left or right. The x-axis is horizontal, the y-axis is vertical. So someone in 6th period said I think this was last week, why can't you just teach us rise over run? Why do we have to learn all this other stuff? This is all application that will really benefit you a lot in geometry next year, and more so in Algebra 2, because you will get into more detail about graphing, not just linear, but quadratic, cubic functions, all that fun stuff. So it's good to know, well, what does rise over run really mean? Why does that work? Any questions on the conclusions from that lesson? Okay, I need you to take some green template blank papers, and you have 4 problems to work on right now. Ms. Wingrove and I just made these up, so these are just problems that are good practice for you. Some have fractions, some don't. Some have plus, some have minus. You are only going to do 4, so you might want to put at the top of them homework and then write down the scenario for each of them before you start. We have about 13 minutes, which is about what I wanted to have with you, so I can walk around and make sure that you know what you're doing, okay, especially because I always take longer with you guys in the other classes, and it's not fair. So get started. I'm going to walk around and make sure you're on the right track, see if you have any questions. What you don't finish in class is homework. That's why it's classwork/homework. Tomorrow, just so you know what's going on, we are going to move on to graphing with slope and the y-intercept, so you won't be graphing with a table tomorrow, okay? On each of your green templates, you need to make sure that you cross off where it says 2 equations or 2 lines and make a table for yourself. Okay, any questions? Okay, let me just stop the recording, and then you guys can keep writing. 'Cause I'd like